Hello, everybody. Hello, Mr. Professor. My name is Zinat Bomba, and my project will be on Linux. Since the middle of 1990, Linux has been around and has grown in popularity. Since then, a global user base. Linux can be used in your tablet, your thermostat, your vehicle, your refrigerator, your Roku, computer, and television, among other places. It also powered the majority of the internet and all of the world top 500 supercomputer and stock exchanges. So, what is Linux? Linux is like Windows, iOS, and Mac OS is a type of operating system is a type of operating system. In reality, the Linux operating system powers one of the most popular platform on the planet. Simply put, the operating system is in charge of coordinating the contact between your software and your hardware. I mean, using Linux is like using all the operating systems like Windows, like Mac OS. It's the same process. It's the link between the computer operating system and the hardware. So Linux longevity, sophistication, and security make it one of the most trusted operating system available today, making it suitable for commercial network devices as well as companies looking to configure their own network and data center infrastructure with Linux and its peripherals. As our operating system, Linux has its story. We're not gonna go through all the story because it's long, but we're gonna briefly tell about the story. We can thanks to the extensive support and distribution. Unix is one of the most commonly used operating system in the world. It was created in the middle of 1917s as a multitasking system for mini computers and mainframes. Linus Torvalds is the creator of Unix, which has created Linux as a small but self-contained kernel in 1991 with the main design objective of Unix compatibility. It has a long story of cooperation between many users worldwide who communicate almost exclusively through the internet. The Linux operating system kernel is entirely new, but it can run many existing free Unix applications, resulting in an altogether free Unix compatibility operating system. That is a brief history about Linux. We will go through the other point, which is the design of the operating system. What is the design goal of Linux operating system? Okay, we'll talk about the fundamental. Linux is a multi-user, multitasking operating system that includes a comprehensive range of Unix compatibility software. Pace, performance, and standardization are the main design objective. Linux is designed to comply with the application POSIX document, and at least 2 Linux distributions have earned official POSIX certification. Rather than following BSD conventions, the Linux programming interface allows SVR for Unix semantics. The following, we have like some other fundamental of Linux. Linux is portable, which means that the software can work on different kinds of hardware, but in the same way. Then it's multi-programming, and many applications can work the same way at the same time. So that is basically some fundamentals of Linux. It's not all of them, but we choose to go through some of them because the presentation don't have to be longer. Okay, the kernel. What is the kernel? The kernel is kind of the core of the operating system. It's the core of all work going on your computer. So in general, the kernel is a system beating heart. It controls the flow of data between the underlying hardware and the peripherals. The kernel ensures that that process and daemons, process and daemon are started and stopped at the correct time. Like when the kernel is on use, you have to know that the process and the daemons are working on the same time and together. So this image shows a little bit of like where is the kernel located and what are probably the elements that function with that kernel, since it's the heart of the operating system. Sorry. Linux has been evaluating over time. So we had first version of Linux, and as times goes, Linux is evolving through times. So in June 1996, version 2.0 was released, which introduced two significant new features. There was support for various architecture, including a native alpha port that is entirely 64 bits. Then the multiprocessor architecture are supported. The operating system licensing. The GNU, which means General Public License, governed by the Free Software Foundation, is put in service to distribute the Linux kernel. It's not allowed that anybody uses the Linux or produce their own Linux derivative. That is not allowed. And the GPL software cannot be sold as a binary only product. Memory management. What is a computer without managing the memory? Here is kind of an architecture of the memory. You can see that there is three parts. There are three parts of memory, but the memory itself is right here by the kernel space. So it has like the body allocation, the zone allocator, the slab allocator, the swap, and the disk driver. So the physical memory management system in Linux is responsible for allocating and freeing pages, group of pages, and small memory blocks. Moreover, it has different mechanisms for dealing with virtual memory. A virtual memory is mapped into the address space of operating system. So this memory image I show you has a physical memory, and the physical memory, which is on the right side, you can see the disk, the physical memory on the right side, and we have also the virtual memory. So the physical memory, all physical pages are allocated and freed by the page allocator, assigning set of physically contiguous pages on demand. To keep track of usable physical pages, the allocator employ a body heap algorithm to keep track of usable, so using the allocator employ a body heap algorithm. Each allocated memory region has enable partner, and when two assigned partner region become available, they are combined to create a larger region. As you can see here, the physical memory is right here, and you will see the allocation, the regions here. Regions are, I'm sorry, the regions are right here and right here. So this image doesn't show exactly how it's represented, but that is what is a physical memory. A virtual memory. Talking about virtual memory, everything that's virtual is like we can't see, but it is still working. A virtual memory is a set of programs and materials that manages the resource from physical memory. So resources come from physical memory and they are managed by the virtual memory. The virtual memory system maintains the address space visible to each processes. It creates virtual memory pages on demand and manages the loading of those pages from disk and the swapping of those pages back to disk and as needed. So the virtual memory manage a program, the materials, and it send it back to the disk. The disk is right here. You can see the disk right here. So there is a communication between the physical memory, the virtual memory, and then the disk. So talking about the virtual, I'm sorry. Talking about the virtual memory, it is essential to realize that the kernel generated a new virtual address space when a process uses the execute system call to start a new program. Meanwhile, the fork system create a new operation that is called to. So after talking about the memories, let's see what does the processor play as a role in managing the Linux operating system. Okay, here is an image of, you can see all the parts of the processor and what each part does. Each processor have a process identity without which you cannot see, the authentication is needed to have security over your your system, your operating system, your files. So here's the process identity. When an application makes a system call to signal changes or wait for another operation, the process unique identifier is used to specify processes to operating system. That process unique identifier is called the PDI, which means the process ID. Or the process identifier, both are the same. And yeah, beside the process identifier, we have credential. In the credential, each process must have user ID and one or more group IDs, which specify the process access to system resources and file. So like you have to have an authentication to be able to access any file, and that is a security that is installed in Unix operating system. We also have the personality. Under Linux, each process has an associated personality identifier that can subtly change the semantic of some system calls, which is not something we will find in Unix system. The process environment. A process takes place on some place. So that place is made of two null-terminated vector inherited from its parent. The first vector is argument vector, a list of command line argument used to start the running program. So you use the argument vector to start is a command line. So you use it to start a running program. And then you go to the second vector in the environment, which is name equal value, pair linking name environment variable to textual value. A process and threads. The process and threads in Linux have doubtless the exact internal representation because of threads, because a thread is simply a new process that happens to share the same address space as its parent. That is to say, a distinction is made only when the clone system call creates a new thread. During that process, the fork generates a new process with its distinct meaning. And the clone establishes a new process with its own identifier, but with permission to share the parent's data structure. Cloning allows an application to have fine-grained control of what is exchanged between two threads. The device management. When we talk about device, you can directly think about input and output. You can directly think about the connection between hardware and software. So the next point is gonna be the device input and output. Here, like you can see some inputs, those are the computers. These computers right here that has everything, the mouse, the screen, everything. And then you will see the output. Here you can see the output. the operating system right here, operating system. So the device management is about the connection between the hardware and the software, the operating system running on your computer. The device input and output. The Linux device-oriented file system uses two caches to access disk storage, including the page cache and the metadata. The page is unified with the virtual memory system, caches data, then the metadata cached in a separated cache indexed by the physical disk block called the buffer cache. To explain all of this, we can say that all devices in Linux are divided into three categories. Among those, random access to comprehensively separate fixed size data block are possibly with block devices. Okay, so that block device provides the main interface to all these devices in the system. Plus the block buffer cache has two main functions. One function acts as a pool of buffer for active input and output, and the other one serves as a cache for completed input and output. However, the request management controls how buffer content are read and written are written from a block system driver. So that was about the input and output management. Let's talk about files. Here is some files that run into Linux. Some of them, Linux has a lot of file system, but we will go through some of them, only some of them. The majority of operations in Linux are performed on files. To handle this file in Linux, we have directories known as folder. Here, we have the directories. Those directories are known as folder maintained in a tree-like structure, although these directories are type of file themselves. So we have the directories, and those directories are also some files. For user, the file system is one of the most important features of the operating system. Files are saved to disk, other secondary storage, and do not vanish when a user log out. It's not volatile. So like when you have your file, they are not volatile. This is a long-term This is a long-term existence property. Another feature is that file can be shared between processes. So you can share your file from Linux okay. So you can share your file between processes. While one process is going on, you can share another file. Files have names and may have access right rights associated with them, allowing for supervised sharing. The third one is the structure of file with them, allowing the to represent relationship between files. They may be organized into hierarchical or more complex structure. So the file may be classified in some type of way. So the majority of operations in Linux are performed on file. So you cannot have an operation going on Linux without using file. So what file is one of the most important parts of using an operating system, especially using Linux. So here are some files now. You have regular file, directories, which is file itself, and special file. So, okay. Security management. But talking about file system, the file system corresponds to the type of formatting that will be applied to partition. It makes it possible to find a file on a hard disk. The entire Linux file system is organized within a single tree structure. Security management. So those are 3 steps through which you should go when you're managing Unix security. You have to get a user account, like to be able to control and assign a single account to each user so that the authentication is efficient. You implement a central privileged access management solution to enable ongoing discovery of Unix and Linux super user privilege. The third and last step is enabling Unix privilege management to control what action user can take while meeting compliance, regulatory, and policies for Unix super user privilege management. User interfaces. So talking about user interfaces, Windows has always come with a graphical interface. However, some server, web, file, BDD do not need a graphical user interface at all. And in this way, resources are used for nothing. So using Windows, like there's no need to be using a user interface. But using Linux, you have a graphical user interface, which can be called X window, and an optional subsystem that you can choose to use or not. Besides, you can start and stop the graphical user interface whenever you want without having to restart the system and without having any effect on running a program. So the user interface can be either a command line interface, which is CLI, or a graphical user interface, which is GUI. Command line interfaces are text-based interfaces using text input and output. So the CLI is based on texts, but the CLI is not that popular. I think most of the people use the GUI, which is graphical user interface, and is the most common user interface using every and any operating system. What are the companies currently involved in this line of business? Like, what are the companies that uses Linux right now? Since Linux is evolving and many people are trying and are learning to use Linux, so it's getting popular. In that case, many companies that uses Linux, probably they all use Mac OS and stuff, but Linux is having a place on the market now from probably the year it has been created, and now it has really evolved. So here are some examples of company that uses Linux right now. So you can see Tesla, Google, IBM, Netflix. So they all use Linux now. And Red Hat, SUSE, and Mandriva are only a few of the companies that have sprung up to provide bundle Linux distribution for mass consumption. There are the future direction. I mean, Linux has like a future direction, because when you see from the starting, from the beginning of the creation of Unix, many people didn't know how to use Linux. They have to learn, read books, and go through information to know how to use Linux. But now, Unix has a brilliant direction. Unix is getting to the market, is getting its place to the market. So I guess in the future, we will probably be using Linux and probably Mac OS and Windows at the same rate, at the same frequency. But I think now people don't really know Linux, but they are getting to know it. Even as students, we use Windows and Mac OS. That's all we use. But I think it should be good for us to be learning also Linux, because it's a really good operating system too, and the security is on point. Okay, so now we just got to the conclusion, and all we can say is like, when Linux was released to the world almost 25 years ago, that was a long time ago. It was model of free and open software that knocked down all of the walls that had previously been put in place. So like, we already had Windows, Mac OS when Linux came into the world. But you can see how fast Linux is growing, how fast people are making Linux grow, so that that operating system can be like one of the powerful one on the world and on the market. So I think to conclude, we'll know that we would say that Windows and Mac OS are really good operating system. There's no doubt they are really good operating system, but Linux has some pros. Linux has a lot of pros for us to be using it everywhere we want to use it, like everywhere we go. And that is a really important operating system in terms of security, in terms of file management, in terms of processor management, in terms of user interface. I think Unix is on point, and I cannot go through some pros and cons of Unix, but I guess in my project, you will be seeing some of the pros and cons of using Linux. So thank you very much for your attention, and I hope I hope you like the presentation, and be kind. Thank you, sir. And yeah, thank you. That was Zena Bomba presenting Linux.